No, that's not
What was wrong?
better than last time. Alright, so.
Is it really though?
Alright guys, so this is our proof here. Now we used the cosine rule, and what we've done is we've rearranged BC cos A and AC cos B formulas. Okay, so bring the B squared over to your side and we get, everybody happy with those two there on the left? Now we don't have any 2's here, do we? So what can I do to rectify that? Divide both sides by 2. Cancel, cancel. Now, plug these two things into the equation up here, yeah? So when we plug the two of these in, what should happen? So, we're going to get is b squared plus c squared minus a squared over 2 plus a squared plus c squared minus b squared over 2. What cancels? What's left? And what will turn into?
T squared.
C squared. Okay, that's tough enough, right? Because it's a bit random. Now,
what did you bring up? Bring it backwards. You brought two equals things up.
yeah, I brought the two of them. This one and this one replace this one and this one.
Yeah, right.
Now, I'll do the harder one for you, okay? The harder one. See there? The one on the right hand side, obviously, yeah? Now, you're going to pick a side to work with. The cosine looks more like the cosine rule. Why am I going to start with the cosine rule instead of the sine rule? Well, just it says cos everywhere, doesn't it? So that's a good start, yeah? Now, we can do a little bit of interchanging, right? So what I'm going to do is I'm going to get the cos on its own. Is that alright? There the office here now. I'm going to get the cos A on its own. Everybody clear with that? How do we get the cos A on its own? Bring the 2bc over to your side. 2bc cos A, and then what happens on the other side then? B squared plus
C squared.
Yeah.
A squared.
Okay. I'd like to get cos A on its own. So how do we do that?
Bring it under.
Bring what under? Sorry, I didn't hear that.
Bring 2bc under.
Is everybody alright with that? Yeah? And also I've done is one piece of the puzzle. Now, we can do the interchange rule. Do you remember what I mean by interchanging? I'm going to change A into B. What does that mean then? If I turn A into B, any B's I see turn into A's, any A's I see turn into B's, all over 2 AC. What about the next one then? What about cos C?
Change C into whatever it is.
So we'll start off here. Change. So what's the difference between cos A and cos C? Anywhere you see a C, turn it into an A. Anywhere you see an A, turn it into a C. Let's find out. B squared, right? C squared, A squared, and then 2bc or 2a b. Now, see all three of these? What am I going to do? Can anybody tell me? This, this, and this.
So the main for the cos A, cos B, cos C.
Okay, let's do that. So, I'm going to have a b squared plus c squared minus a squared all over 2bc, and then it's all going to be divided by, but the a effectively multiplies by the denominator, doesn't it? So example, what would be 2/3 divided by 5? The answer is 2/15. The 5 effectively goes up, turns upside down, and multiplies by the 3. So I'm effectively going to multiply the two denominators in the same fashion. Does that make sense? So I'm going to get 2 ABC. Is that right? 2ABC, okay? Now what about the next one? What about the middle part? We're looking for cos B, aren't we? So what's cos B? Cos B, anybody? A squared plus C squared minus all over 2AC divided by B. See the B? And then what would that become? 2ABC. And then finally the last one, which is cos C. I'll just grab it there, won't I? Just move it down here. So what is it? B squared plus A squared minus C squared all over 2AB. And what's that divided by on the bottom? And then what happens to the C? Goes up, doesn't it? Now, do they all have the same denominator? How many B squares do we have? Or A squares? 1, 2, take away 1, A squared. 1, 2, take away 1, and then. Is that okay? Tough, wasn't it? You need to look at that again, obviously, yeah? Yeah, okay. Now, whoa, prove this one. Okay, when I'm picking these, I generally pick the one with the largest side. Which one's larger? What? The right side. Could I multiply out the right side? Can I multiply out the right side? How's when I multiply it out? Yeah. And? Sine row or cosine row?
Cosine.
Okay. What should I try to get on its own?
Cos minus 2BC cos.
Bring it to the left. And bring the other ones to the right. What am I going to do now? Do you want me to try the interchange trick?
Yeah.
Okay.
2AC cos B.
2AC cos B. What do I have to do there? Anytime I see a B, turn it into A. Anytime I see an A,
C.
there you go. What about the next one?
AB cos C.
Yeah. Anywhere, depends which one I'm using as the reference, doesn't it? I'll tell you what, I'm going to use the one above it. I'm going to change that one to the one below. So I'm effectively changing C and B. Does that make sense? So anywhere I see a C, I turn it into a B. Now I have all three answers, don't I? And what can I do underneath them?
Take away the one with 2.
No, I don't have to do that. Look at it. There's already 2. So replace that with what goes?
2BC cos A. So B squared plus C squared.
Next one.
A squared plus C squared plus B squared.
One after that.
A squared plus B squared.
What happens next? It's just going to be A squared plus B squared plus C squared, isn't it? 2 of them take away 1 of them. Difficult enough, right? Okay. And last one. Okay. First of all, how do I show that cos 180 minus theta equals minus cos theta? Anybody remember the compound angle tricks? What's cos A minus B?
2 sin A plus B over 2.
What about cos A cos B minus sin A sin B? See it?
No, I thought you were doing cos A minus cos B.
Yeah, they're within the angle, aren't they? What's A going to be equal to?
180.
180. What's B going to equal to? Okay.
Minus theta.
And I'll just theta because the B matches up with the theta, the minus is taken into consideration. Now, here's the fun part. Cos 180 is minus 1. What's sine 180? 0. Is everybody happy that I'm just after proving that sine 180 minus theta is minus cos theta? You good with that? Now, what does the first question mean? Part 2. Express cos alpha and cos beta in terms of labelled lengths. What does it mean by labelled lengths? What's A looking at? What's alpha looking at? C squared equals P squared plus D squared minus
2PD
cos. Get cos alpha on its own. So 2PD cos alpha is equal to what? P squared plus D squared minus C squared, and then at the end cos alpha equals
P squared plus D squared plus C squared all over 2PD.
yeah. Okay. Do the same thing for cos B, yeah? So what's it going to be? B squared equals yeah, yeah, minus which one? 2 minus 2 dq cos beta. Is it alright for me to just skip to the finish here because it's exactly the same as last time, yeah?
Yeah.
So cos B equals D squared plus Q squared minus B squared all over 2dq. Is that right? Right, alpha in terms of beta. Now, see this hint here? That's the only reason I know how to do this. What's alpha plus beta? So, alpha in terms of beta. Have you enough of that? Makes sense, wouldn't it? From the first part.
So that's being an
Yeah, it's alpha.
Brain's gonna throw everything.
Alright. You're going to get to look at it later, aren't you? Now, hence or otherwise show that. Now look at this, guys. How's that? What letters are missing? Is there any letters that are missing? Oh yeah, so alpha and beta are gone, aren't they? So that's a hint, isn't it? The angles are gone. So that's something we should start off with. Okay, so let's try it like this, right? So why don't we try cos alpha equals what? Cos alpha equals cos 180 minus beta. Would you agree with that? Yeah? And what can we change 180 minus beta into? Look at part 1. Huh? Minus cos beta, yeah? Now, how do we get rid of cos alpha and cos beta? What can I put in instead of them? Dan's just looking you straight in the face.
P squared.
P squared plus
D squared.
minus all over. And then after that, what did we say earlier? D squared plus Q squared minus B squared all over. What is it? 2dq. Now, have to do that, don't I? So how on God's green earth do I get from this to this? Right? interesting, isn't it? Now, why don't I give them a common denominator? How do I get them a common denominator?
2b bracket 2bq.
Why don't I put a q here and a p there, and then that means I have to multiply this by and this one by p, and I'll see what happens. So multiply it out, qp squared. Yeah. What else? qd squared. Yeah. Anything else? Minus qc squared. Yeah. Anything else? pd squared. Yeah. Anything else? pq squared. Yeah. Anything else? pb squared. Now, what do I want on the left hand side on its own? Oh, no. The qc squared and the no. I have them, but they're the wrong signs. So I'm going to see if I made a mistake somewhere. Oh, minus. See the minus? So, how do I spot that? The PB squared and the QC squared have to be the same sign as each other, yeah? So if I move the PB squared over to the QC squared, one of them is going to be plus, the other one is going to be, which means I had to go looking for a minus in my mistake, and then I realised, oh look, I forgot the minus, it was minus cos B, so that makes that a minus, that a minus, and that a plus. Does that make sense?
Yeah.
Now let's get this together, right? Bring the QC squared over there, so it's going to be QC squared plus PB squared. You happy enough with that? Then what are we going to put over the other side? We have our QP squared, our QD squared. What else do I have to move over? I have to move over a PD squared, don't I? And a, what else? A PQ squared. Yeah? Now, if you aren't sure if these are the same things or not, you could just multiply these out, couldn't you? Just multiply these out for a second, and you get P squared, Q, PD squared, PQ squared, and PD squared. Are they exactly the same as that there?
Yeah.
Different order perhaps, but the same thing. So you just have to prove that QC squared plus QP squared is in fact P plus Q and Q plus T squared. Alright guys, I reckon you did the ones I did.
Yeah.
So 7, 9, 3, 4, 7, 9 guys. And maybe 1, 2 as well. 1, 2, 3, 4, 7 and 9. I'll put that up on YouTube.